So this is the 5-step process that I've been teaching my students to solve single variable inequalities. When the directions say solve the inequality, it means apply these 5 steps. So here's the inequality that we'll start with. 3x plus 8 is greater than 44. Step 1 is to find the boundary point. Finding the boundary point is finding where the left side of the expression of 3x plus 8 is equal to 44. That's the start of the values that will make a true statement with this inequality. To solve this equation, we first need to get x by itself, and it's already on the left, so basic equation solving techniques are applied, and I take 8 from both sides. These are opposite values. Adding 8 and taking away 8 removes that adding of 8, cancels it out. They have a value of 0, and I'm left with 3x. The remaining value on the right-hand side is 36. On the left-hand side, 3x. 3 is being multiplied by x. To cancel that or undo that property, I'm going to divide by 3. To maintain equality, divide both sides by 3. So x equals 12. This is the boundary point. So now that I have my boundary point, step 2 is to graph this boundary point on the number line. These are all the values that are representing the possible values that x can be that would make a true statement in the inequality. That boundary point gets placed in the middle, and then I've told my students you only need to establish a scale. So if I'm counting by 1, those are the other 2 numbers on my number line. The original inequality here says that the value of x will be greater than or less than that boundary of 12. It is not equal to that value. So on the number line, putting an open circle to indicate that the boundary is 12, but it does not include 12 itself. Step 3 is to find a test point. And I put on my first note that I usually test 0 because it makes the math a lot easier. So I'm testing if x equals to 0. So always start with the original inequality. I'm replacing the value of 0 in the equation. On the left-hand side, I have 3 times 0, which is 0, and then plus 8. I really only have 8. So 8 is greater than 44. This is a false statement. 8 is not greater than 44. 44 is greater. So that means that my value of 0, so when x is equal to 0, it makes a false statement. That means x is not equal to 0. So the side of the number line over here that contains 0 is not part of my solution set. The side over here that does not contain 0 is my solution set. So all of these values over here make up the solutions to my inequality. So I can put in another value such as a nice even number like 20, and I can put 20 into my inequality. 3 times 20 is 60, 60 plus 8 is 68, and 68 is indeed greater than 44. If I put a number on this side into my inequality such as 10, 3 times 10 is 30, 30 plus 8 is 38, and 38 is not greater than 44, so it makes a false statement. The last thing to do is the final inequality. This is step 5. Step 2 was to mark the boundary point. Step 3 was to do the test point. Step 4 was to graph the solution set on the number line. And step 5 is to write the final inequality. The values for x on the left-hand side of the number line makes those values greater than, but not equal to, 12. That is my final answer, and the final answer actually includes the number line and the inequality. All that together makes my final answer. I just wanted to quickly point out, I do realize that my solution side is actually on the right side and not on the left side. So this new equation, 4x plus 2 is greater than or equal to 9 times the quantity of x minus 2. It's a larger inequality, more stuff to do, more steps, but as long as we follow basic equation solving techniques to find the boundary point, it makes it a doable problem. So step number 1, solve the equation of when the left side is equal to the right side to find the boundary point. So I've already solved the equation. The boundary point is when x is equal to 4. So now in graphing my boundary point, I look up to my original inequality, and I know it says greater than or equal to, but it could also be less than or equal to a value of x depending on the numbers. But the key thing that I'm looking at is this line here. This line indicates that this boundary point of 4, when I put in the boundary point of 4, that's when the left side is equal to the right-hand side. And this says that's possible. It says that it can be equal. So that means when I graph my boundary point, I need a closed circle because 4 is in the solution set. So I use the original inequality and test when x is equal to 0. I can test any number I want to. There's an infinite number of numbers to test, but I usually use 0 because it makes the math a little easier. So 4 times 0 is 0, and 0 plus 2 is 2. Inside the parentheses on the right-hand side, 0 minus 2 is negative 2, and 9 times that negative 2 is negative 18. I end up with 2 is greater than or equal to negative 18. That is a true statement. As a true statement, it tells me the side over here that contains x is part of my solution set. X can be equal to 0 because it makes a true statement as my test point checked. That means all of the values on this side of the number line that contain 0, that is my solution set. So I just completed step 4, which is graphing the solution set on my number line. Step 5, the final inequality. For the values of x, all of the values of x are less than or equal to 4. My final answer then consists of the number line and the final inequality that show that all of the values of x in this inequality will make true statements as long as they are less than or equal to the value of 4.